Hey class, Mr. Houston here, back to talk to you about another exciting episode of probability. Today's use of probability will be talking about a special kind of probability known as permutations. Permutation is just simply an arrangement of items, and in this case where order matters. So we're going to talk about, in the next lesson, we're going to talk about combinations where the order doesn't matter, but in permutations, the orders do matter. All right, so we will be using some different things to solve for permutations. So let's take a look at example number 1. Consider the number of permutations of the letters in the word July. So question A says, in how many ways can you arrange all of the letters? So first off, we need to know how many letters there are. In this case, there's 4 letters. So go ahead and make 4 little lines there. In the first spot, how many options of letters do we have? J, U, L, and Y. So we have 4 options there. Okay. Now once we use up one of those letters in the second spot here, how many more letters are we going to have to use? And the answer is 3. Go on to the next one, we'll find that it's 2, and then the last one will have 1 option left. Now I'm not saying exactly which letter it is, it's just a matter of if I've used up 3 of the letters already, this last one, there's only 1 option left to use. So to figure out the number of ways you can arrange that, you just multiply them all together. 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. So there are 24 ways to arrange 4 letters in the word July. All right, let's contrast that with letter B. And how many ways can you arrange 2 of the letters? So in this case, we're just talking about 2 spots. And so we have how many options for the first letter? We would have 4. And then we take one of those away, and we would have 3. So to arrange 2 letters, we would have 12 different ways to arrange 2 of the letters. Okay, so just a brief introduction into a permutation. We would say the number of permutations would be 24. The number of permutations is 12. Now, sometimes things can get a little more difficult. Okay, when that happens, we have 2 formulas here. We have this one, and we have this one. So when it says the number of permutations of n objects is given by this. So basically up there when we were talking about having the number of permutations of all the letters in the word July, that would fall under the first one, n factorial. What that means is a factorial, so like 4 factorial is 4 times 3 times 2 times 1. So it's multiplying all of the numbers underneath of it or below it with that factorial. So when that's the case, we use just n factorial. Now in the case of the other one, where we had 4 letters in July and we're only using 2 of them, we're going to use this one. The probability or permutations of, in this case we had 4 letters, but we were only taking 2 of those letters at a time. Okay, so I guess I should have looked here. They actually kind of did that for us. So again, we are using factorials to do this. Again, factorials is just multiplying all the numbers underneath or below whatever number that is. All right, so let's put that into use here. So your band has written 12 songs, and you plan to record 9 of them for a CD. And how many ways can you arrange the songs on the CD? So this is a permutation. We have 12 total items, and we are taking them 9 at a time. So our formula up here is n factorial. So n is the total number, 12 factorial, over n minus r factorial. So 12 minus 9 factorial. Oops, close that up. So we're going to simplify that. That's going to give us 12 factorial over 3 factorial. Now, I don't know if there's a button on the calculator or not. One thing I like to do is we'll just take these out, 11, 10, 9, 8, 7, 6, 5, 4, and then I'll stop at 3 and put 3 factorial, because when I do that, I can have this 3 factorial on the bottom, and they can cancel each other out. Now, in a case like this, that doesn't save us a whole lot of work, but what it does do is allow us to see, okay, I'm going to take the top part out as far as I can until I get to the bottom one so I can cancel them out. And then all you're going to do is you're going to multiply 12 times 4 all the way down. You will find that there are 79,833,600 ways to put 9 songs. To take 9 songs out of the 12 that you have made to put on a CD. All right. Now, obviously, I'm not going to ask you to list out all the different ways you can do that, but you can see that there are lots of options, lots of permutations when you have a large number of items that you're only taking a few of at a time. All right. So, for a town parade, you will ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second. All right? So we're going to do this very similarly to what we did in our first lesson. We're really only caring about who's first and who is second. Okay? So, again, we're talking about kind of a theoretical probability. So what is our favorable outcome over the total number of outcomes? And in this case, the way you want is probably that your float is first. So how many soccer floats will there be in this parade? Most likely there's only one, but there are 12 floats. Okay? And then how many school chorus floats are there going to be? Again, hopefully only one, but now we've already hopefully chosen ours first, so there should only be 11 options left. So we will multiply 1/12 times 1/11, and we'll get 1/132. Okay, so that's how you would find probability that your float is chosen using different permutations and such. Just know that we had to bring the number down a little bit. All right. Okay, so those are permutations. If you have any questions, again, big key here is making sure that we know these formulas. If you have any questions, bring them with you to class, and we'll see you then.